This next topic is somewhat unusual. I think it's important, and it's normally not included formally in our textbooks on information or our textbooks on physics. This will be section 44.5, and we want to talk about data and metadata. This is kind of common sense, but sometimes it's good to bring our common sense ideas to the forefront and codify them as best we can. First of all, data is usually meaningless by itself, except as an abstract number. I mean, we can talk about the number 4.72. Okay, that's a number. And we can deal with that mathematically. But without knowing what units it has or what it refers to, it's meaningless in the physical world. So we need to give more information. And one way to do that is to say our data should have a form of what is the data? That's 4.62. What are the units? Feet. And what is it referring to? Length of table A4. And here we have three components of our data. We have a numerical value, presumably in scientific notation with the associated accuracy, the units associated with that data, and what that's really referring to. Is it a number of cows or sheep, or is it the length of a table, or what does it really mean? And so this is normally called the data, and this is called the metadata. If you wish, you could actually include the units in with the data, depending upon how your terminology works, but certainly the associated information about what we're measuring. I've given some examples here of Jack's mass. It's in kilograms, and I could talk about this without knowing the numerical value. I could say, what is the value in kilograms of Jack's mass? And it wouldn't have a data. And I could also say, this many kilograms is Jack's mass. Here I've included both the data and the full metadata. The data usually takes the form of a scientific number, but it could be a symbolic number, like E or pi or I or infinity. It could also be a range. So you could say that your data was in a range from here to here. Your data could also be in the form of a function, like f of x and t, function of two variables. Your data could also be in the form of a set of matrices, such as a network, which is described by a matrix of connectivity, or a vector, and we could have an R vector. So we could have a vector with components x, y, and z, referring to a position r or velocity, or force, and then units associated with it, and then what it was referring to.